There are moments in our history when the universe seems to whisper back. For centuries, we have looked toward the red planet, our restless twin, and wondered, is there life out there? Or are we alone in this vast, unfeeling expanse of the cosmos? Now, for the first time, that question is no longer philosophical, but physical, tangible, visible, etched in stone and shadow upon the surface of Mars, the red planet. This is the story of the Emerald Enigma, a discovery that could redefine not only what we know about Mars, but what we understand about ourselves.
So this very well could be the clearest sign of life that we've ever found on Mars.
Billions of years ago, the Jezero Crater was alive with water. A lake, a delta, a flowing network of rivers carving veins across the ancient dust. Today, it lies still, only dust, a fossil of a world that might once have breathed because it was alive. And somewhere in this quiet basin, the NASA rover Perseverance found a rock, small, unassuming, yet upon it, a pattern that would change everything. A new scientific discovery was born. Tiny dark specks arranged like constellations across its surface. NASA called them leopard spots. But when we looked closer, they seemed to whisper of something more. Under the microscope of Perseverance's instruments, those dark spots revealed two familiar companions. Minerals born of iron, called Vivianite and Grigite. On Earth, we find them only in the quiet company of decay, in the patient work of microbes breaking down the remains of life. Vivianite, the mineral of life's aftermath. Grigite, the whisper left by something that once was. It was, as one scientist murmured, the closest thing we've ever found to fossilized breath. We've been here before, on the edge of revelation, our hearts pounding with hope. But never quite like this. The rock, no larger than a 6-year-old child's hand, was found in the ancient delta of Jezero Crater, a place where rivers once spilled into still water. Sedimentary layers preserved beneath Martian dust told stories of a time when the planet may have been alive. Within them, organic compounds, carbon-based molecules, the ingredients of existence. On Earth, such rocks cradle fossils, time capsules of worlds long gone. On Mars, they might cradle something even more profound, proof that life is not bound to Earth alone. In February 2021, Perseverance touched down on that ancient lakebed. We called it Jezero, the crater that once held water deep enough to host rivers flowing in and out. A place carved by time, by sediment, by chemistry. It was there to hunt for the oldest question we've ever asked. Was there ever life on Mars? If it could happen anywhere, it would happen there. Ancient lakes, rich in clay and minerals, hold secrets that water never fully erases. They preserve traces, tiny echoes of life, if life ever was. For months, Perseverance explored the fractured basin, and one July morning in 2024, its cameras caught something unusual. A rock from the Bright Angel Formation, a formation rich in clay and silt, the kind of material that, on Earth, holds the imprints of ancient life. Two instruments took the first close look. PIXL, the Planetary Instrument for X-ray Lithochemistry, and SHERLOC, the Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. What they found inside that modest stone made the world lean forward in silence. It was rich in organic compounds, carbon, phosphorus, and iron, arranged into rings. The scientists nicknamed them leopard spots and poppy seeds. Tiny, but enough to make astrobiologists' hearts race. The light inner part of each spot was similar to the surrounding rock, but the dark rims, those faint halos, were different. They were enriched with iron and phosphorus, as though something once moved through the stone, changing it from the inside out. Perseverance's instruments also detected organic molecules, the kind that on Earth are intertwined with life. And based on the chemistry, the texture, the balance of elements, this rock had once been in contact with water. Where there is organics, water, and iron reduction, there is always the possibility of life. That's when we began to ask the forbidden question again. Could this mudstone hold the first alien biosignature ever found?
Today, we are really showing you how we're kind of one step closer to answering humanity's one of their most profound questions, and that is, are we truly alone in the universe?
At the center of the mystery were those two minerals, Vivianite and Grigite. Vivianite forms when microbes, in the absence of oxygen, use iron as their breath. They consume iron 3 oxide and release iron 2, a waste product that, when meeting phosphate and water, becomes Vivianite. Grigite forms in a similar way, but in sulfur's domain. Certain bacteria on Earth break down sulfate into sulfide, and that sulfide reacts with iron to make Grigite. It is a subtle alchemy, life whispering through chemistry, leaving minerals as echoes of its passing. But what if we were wrong? What if it wasn't life? We tried to explain it without life, as scientists must. Could volcanic heat have done it? Could some ancient chemical reaction have imitated biology? Maybe the sulfide came from hot gases leaking into groundwater, forming Grigite without any help from microbes. But the rocks told another story. There was no evidence of volcanic activity here, no heat, no hydrothermal scars. Could it have been acid? Acidic water can mimic the patterns of life, dissolving and redepositing minerals in strange, delicate rings. But then Perseverance saw something that shattered that idea. Olivine. Olivine is fragile. It dissolves quickly in acid. Its very presence meant one thing, and one thing only. This place was never acidic. And so, one by one, every lifeless explanation fell away. What remained was a quiet, stubborn paradox. Vivianite cannot form in heat. Grigite cannot survive in acid. And yet, both existed together in the single stone. The simplest answer was the hardest to accept. Life once moved here. Science, however, is patient. It is not the art of proving rightness. It is the discipline of trying to be wrong, again and again, and failing to be wrong. For months, the Mars team tested every hypothesis they could imagine. Could pressure, temperature, or radiation have caused these patterns? Could pure chemistry create Vivianite and Grigite in harmony? Each attempt at a lifeless explanation dissolved in contradiction. And so, after months of study, one conclusion remained. We couldn't prove this was life, but we also couldn't prove it wasn't. Still, we've been misled before. In 1976, the Viking landers tested Martian soil with a bold experiment. They mixed it with nutrients labeled with radioactive carbon and watched as the soil breathed out carbon dioxide. For a heartbeat, we thought we'd found life. But years later, we learned the truth. It wasn't biology. It was chemistry. Perchlorates in the soil reacting violently with water. A false dawn. Then came 1996. A meteorite found in Antarctica, ALH 84001, believed to have come from Mars, seemed to hold fossilized microbes inside. The world stopped. President Bill Clinton stood before the cameras and said, "This may be one of the most stunning insights into our universe." But again, hope unraveled. The tiny shapes were mineral, not microbial. Life had not yet whispered back. And yet, here we stand again, 50 years later, looking into a Martian stone that refuses to fit into silence. In July 2024, Perseverance drilled into that rock, Chayava Falls, and sealed its core in titanium. One of 27 samples waiting quietly in the Martian dust, each one a page in a library of alien history. The plan is simple in dream, complex in execution. Launch another rover, collect the samples, send them home. The Mars Sample Return Mission. But dreams are expensive. $11 billion, 3 spacecraft, 1 chance. Phase 1. Perseverance has already done its part. Phase 2. Send another spacecraft to gather the tubes, launch them into Martian orbit. Phase 3. An orbiter retrieves them and brings them across the gulf of space, home. If all goes as planned, if politics, budgets, and patience align, we may hold that Martian stone in our hands one day. And when we do, we'll finally test it in ways no rover can. We'll look for 2 fingerprints of life. The first is chirality, the handedness of molecules. Amino acids come in 2 forms, like left and right hands. On Earth, life overwhelmingly chooses the left. Non-living chemistry, by contrast, makes both equally. If the Martian sample shows a clear preference, one hand over the other, that could be the unmistakable mark of biology. The second fingerprint is carbon isotopes. Life prefers lighter carbon, carbon-12, over its heavier sibling, carbon-13. If the rock's carbon ratios match those of living systems, we may be staring into the face of Martian biochemistry itself. NASA calls this the confidence of life detection scale, a ladder of certainty 7 rungs high. From "it could be life" to multiple teams have proven life beyond doubt. Right now, we stand around level 3. Bring the samples home, maybe level 6. To reach level 7, we'd have to find life again, in a completely different place. Even then, we must remember, this isn't just about Mars, it's about us. Mars is a time capsule of an early Earth. Unlike our restless planet, its crust has stayed frozen for billions of years. No tectonics, no oceans shifting continents, no erasing the scars of time. Its rocks still remember what Earth has long forgotten, what our world looked like when life was still just an idea in chemistry's mind. So when we study Mars, we're not just looking outward, we're looking backward, toward our own beginnings. But what if the sample does turn out to be life? Then the implications ripple through everything we know. First, it would mean Mars was habitable far longer than we imagined, that it held water, warmth, and chemistry long enough for biology to begin. But deeper still, it would transform how we see life in the universe. Because if life happened twice in one solar system, then life isn't rare, it's inevitable. The Drake equation, that ancient thought experiment of the cosmos, would shift. The fraction of habitable planets that develop life, once near 0, would leap closer to 1. 2 worlds, 2 sparks. And in that instant, the universe becomes alive with possibility. But there's a caveat. It changes everything only if life on Mars arose independently. If we and Mars share ancestry, if we are cosmic siblings born of the same seed, then it still counts as one origin story, a single spark scattered across 2 worlds. There's a concept in astrobiology known as the 0-1 infinity rule. Life can exist in 0 places, 1 place, or infinite places. We already know it's not 0. If it's 1, we're alone. But if it's 2, if both Earth and Mars gave birth to life, then why not 5? 5,000? 5 million? Infinite? If the universe can repeat the pattern once, it can repeat it endlessly. And that realization would change everything. Not just our science, but our sense of self. We would no longer be the exception. We would be the rule. And maybe in that humbling truth, we'd finally see our place among the stars, not as masters, but as participants in something grander. For now, perseverance waits. Its metal eyes stare across the sealant plains of Jezero, watching dust swirl in thin Martian light. It carries a story billions of years in the making. A story that might prove that life is not a miracle, but a habit of the universe. We've spent our lives searching the sky, wondering who might be out there. Maybe what we're really finding is a reflection of ourselves, long lost among the stars. The Emerald Enigma, a rock no larger than a human hand, but heavy enough to bend the course of human destiny. And when that rock finally returns home, when we peer into its core beneath our own sky, we may see not just the traces of life on Mars, but the echo of life on Earth. Because the line between the living and the lifeless was never a wall, it was a threshold. And Mars may be the first door we ever open